Okay, the second subtopic, which is the final subtopic in this chapter, which is on centripetal force. Okay, so in this subtopic, you have to be able to define what is centripetal acceleration, solve problems related to centripetal force for uniform circular motion cases, which is on horizontal circular motion, as well as vertical circular motion, and conical pendulum, excluding bank curve lah. Okay, so what is centripetal force? Well, centripetal force is a force that is associated with centripetal acceleration. Okay, so if there's a centripetal acceleration, there will be a centripetal force lah. Okay, so this one is the derivation. So the formula for the centripetal acceleration force is the one here. You have to be able to use this formula. The derivation part is just so that you understand where it comes from. Well, it's basically just Newton's second law of motion, which is force equal to ma, and in this case we are saying that the acceleration is equal to the centripetal acceleration. This one should be c. I'll edit that later. So the net force is then equal to the centripetal force. Okay, the centripetal force is not in your free body diagram. You cannot write a centripetal force in your ow my cat. Okay, sorry. So it's okay, so the the total force is basically just equal to the centripetal force lah. Okay, so we can then write the F equal to ma in terms of centripetal punya situation lah, which is Fc equal to mac, lepas tu centripetal acceleration is equal to this lah. Okay, so just read that on your own if you want to understand more on how the derivation works and how we get this equation here. Okay, so the centripetal force is defined as the force acting on the body causing it to move in a circular path. Okay, so remember we have different types. We have external force, which is only push or pull. It can cause the body or the object to move up and down, or to the right and to the left. But then centripetal force ni pula, it causes an object to move circularly lah. Okay, so how do we find that magnitude? How do we find that value of force? Is by using this formula, mv square over r. Okay, so it is basically the same with the centripetal acceleration, in which it is directed towards the center of the circular path. Okay, so it has the same direction as the centripetal acceleration. As you can see here, they are pointing towards the same direction. Okay, right. So if the centripetal force suddenly stops, okay, so remember this force is causing the object to move circularly. Then what happened if it suddenly stop? Suddenly they stop. So there's no force causing the object to move now, move circularly. So what happened is the object will then move linearly lah. Okay, so it will move to a straight line, macam tu. Okay, so we call it as linear speed lah. We don't call it as a tangent. I mean, it will not move circularly lagi lah. It will move linearly. Okay, all right. So what else? This is okay. So the net force on a system for centripetal force. Okay. So in uniform circular motion, the net force is the centripetal force. So basically, what it's saying is F net is equal to Fc lah. Okay, and then the work done by the centripetal force is 0. Okay, work done is 0 kalau centripetal force. However, mestilah work done 0 because it needs a change in displacement kan. Tapi sekarang ni semuanya points towards the center, so it will equal to 0 lah, right? Lepas tu, however, the kinetic energy is not 0. So there is a presence of kinetic energy, and how you calculate it is by using this formula here. Right, so I'll go into this forces in uniform circular motion in the next video.